I am Karuppathal, Associate Professor of Department of IT. I am going to present a seminar on 8086 microprocessor. The contents of the seminar is features, architecture, instruction set, addressing mode and programming. First we will see about features. It is a 16-bit processor, so it can process a 16-bit data at a time. So it has 16 address lines. Then it has 20 address lines, so it can address 1 megabytes of memory at a time, and it can operate in minimum and maximum mode. So minimum mode means it operates in a single processor mode. Maximum mode means co-processors can be connected. Then the operating supply is plus 5 volts DC supply, and the clock frequency is 5 to 10 megahertz. Then this is the block diagram of 8086. It consists of two parts. One is bus interfacing unit, another one is execution unit. So the bus interfacing unit, functions of the bus interfacing unit is it sends out the address and it fetches the data or instructions from the memory and read or data from the ports and memory. Then the contents of the bus interfacing unit is the queue register, segment registers and the instruction pointer. So the segment register stores the base address of the segmented memory. That is, the base address means starting address, and the queue register will store the instructions fetched from the memory, and it operates in the first in first out operation. Then the instruction pointer stores the offset address of the memory, that is program memory. There are 4 segment registers. One is extra segment, code segment, stack segment and data segment. This instruction pointer, and the code segment is mainly used for program storing the address of the program. So the code segment register contains is 16-bit. All are 16-bit registers. So if it contains 4300, and the instruction pointer shows the offset, that is displacement. One, two, three, 4. Then the physical address will be calculated by shifting the code segment by 4 bits and adding the offset from the instruction pointer. So segment shifting code segment 4 bits left means it will be 43000. Then the IP, that is instruction pointer contents is 1234. So this will be added. So this will be 44234. So the physical address is 44234. So this will be sent out to the processor. So the data will be retrieved from this address and it will be sent to the execution unit. Then execution unit functions are, it tells the BIU where to fetch the instructions or data, then decodes the instruction, that is the operation to be performed is identified and execute the instruction. Then contents of the execution unit is ALU, flag register, general purpose registers, pointers and index registers. So the ALU will perform all the operations, arithmetic operation, logical operation and other operations indicated by the instructions and stores the result. Flag register will indicate the status of the operation, and general purpose registers are used for storing the data during operation, and the pointers are used to point the or store the offset address, and index registers for storing the offset for string operations. It consists of 5 flags. From the diagram we can see that it consists of, it is a 16-bit processor, so it consists of general purpose registers, 4 general purpose registers, stack pointer, base pointer, SI register and DI register. These two are in DI and SI registers, especially used for string instructions. Then pointers are used for storing the offset address. Then these are 16-bit registers. They will be divided into 2 parts, that is higher register and lower register. Higher register and lower register of 8 bits. So it can operate in 8 bits also. So the arithmetic arithmetic logic unit, that is ALU, it controls performs all the operations like addition, subtraction, multiplication, division, and the logical operations and or not and the complement. Then the result is stored in the accumulator, that is AX register or AL register for 8-bit operations, and the status will be indicated by the flag register. So it consists of 16-bit flag register. Out of 16 bits, only 9 bits are used. So out of that, 6 are status flags and 3 are the conditional flags. So 6 status flags are carry flag, parity flag, auxiliary carry, zero flag and sign flag, and another one is overflow flag. Carry flag, if the result of the operation is more than 16-bit or more than 8-bit for 8-bit operations, the carry flag will be set. Then parity flag, so parity means we know that is number of ones, it is indicated number of ones. So if even parity, it is set. Then auxiliary carry is set when a carry is generated in the lower nibble of the operation, that is addition, and it is carried over to the higher nibble, that is 4 bits. The auxiliary flag will be set. It is not user defined. And zero flag, if the result of the operation is 0, then zero flag will be set. Then sign flag is used for signed arithmetic operations. So if the result is negative, it will be set, otherwise it is reset. And overflow, the magnitude, we have to differentiate the overflow and carry flag. So carry flag means number of bits we have to consider, and overflow flag, the magnitude exceeds the defined value, that is 2 power 16 for 16-bit data, and the overflow flag will be set. The direction flag, interrupt enable flag and trap flags, these 3 are the control flags. So the direction flag indicates the data flow of direction, that is from or to the register. Then interrupt flag, if any external interrupt or internal interrupt occurs, this interrupt flag will be set. So this can be user defined, can be set by the instruction STI or cleared by using the instruction CLI. And the trap flag is used for debugging. During debugging, we can execute the instruction program instruction by instruction. So instruction by instruction, it is executed, the contents will be viewed. So for that purpose, the trap flag will be used. Then we will go for the instruction set of the processor. So the instruction set is classified into 5 categories: data transfer instructions, data manipulation instructions. Data manipulation instruction is again subdivided into 2 parts. One is arithmetic instructions, another one is logical instructions. And the third one is program control instruction, then machine control instructions, and the string instructions. Then we will see one by one. Data transfer instructions. Data transfer instruction means they will be transferring the data from source to destination, and no flags will be affected by this data transfer instructions. The possibilities of the sources are a memory, IO device, data, and possibilities of the destination are only memory, register, that is all. And we have to note the point, no data should be the destination. Data transfer instructions, so they will transfer the data from source to destination. The source can be a memory, register, a data, and the destination can be only the memory or a register, and IO device is possible. And this data transfer instructions won't affect any flag, that is no flags will be affected. So we can go for the examples. Data transfer instructions from source to register are thus, we have to use the instructions move destination comma source. So destination can be memory, register, or an output device. Source can be memory, register, and an input device, and another possibility is data. So the important point to be noted here is data should not be a destination. That is important point we have to note here. And for IO device, special instructions such as in port address, out port address are used. Then next type of instruction is data manipulation instructions. Data manipulation instructions are again subdivided into arithmetic instructions and logical instructions. Arithmetic instructions performed by the 8086 processor is addition, subtraction, multiplication and division. Then we will see the operations of one by one. First one is addition. So addition means it can perform either 8-bit or 16-bit addition. So 8-bit means already we told that AL register will be used, and 16-bit means AX register should be used. So we have to take care whichever data is used. 16-bit means both source and destination should be 16-bit. 8-bit means source and destination should be 16-bit. So the operations used, instructions used are add, destination, comma source. So the destination is mostly we have to use the accumulator, and the source will be similar to the data transfer instruction, that is memory, register, and an immediate data can be used. And another one instruction is ADC, same type, that is destination comma source. That means the carry flag, if the previous operation, if carry rises, the carry is also added. So here the accumulator contents will be accumulator plus the source data. Here accumulator equal to accumulator plus source plus the carry data. So that will be stored in the accumulator. The result will be stored in the accumulator. Another one is INC, that is increment register. So this will be increment the content of the register, that is the content of the register will be added by 1. Then subtraction. Subtraction is similar to addition. The rules apply, the source, destination and this. and multiplication, the instruction used is MUL, register. So MUL register means the contents of accumulator and the contents of the register is multiplied, and the result will be stored in, if you are using an 8-bit data by 8-bit data, the result is stored in AX register. That is, lower 8-bit is stored in AL register and higher 8-bit is stored in AH register. If you are using 16-bit multiplication, the lowest 16-bit product is stored in AX register and DX register will store the highest 16-bit of the product. So that is the special function of DX register. Then division is similar to multiplication, that is DIV, the instruction used is DIV register. So this will perform the operation DIV DX AX divided by the register. So during division we will get the answer as quotient and remainder. This quotient is stored in AX register and the remainder is stored in DX register. So the DX register is a special function used for multiplication and division. Then logical operations. Logical operations performed by the 8086 processor is AND operation, OR operation, XOR operation and complement. And OR, XOR similar to addition, and the complement operation, that is form method AND register, XOR OR register and XOR register. So they will do the operations and the corresponding flags will be affected. For complement operation, 1's complement and 2's complement, there are separate instructions are used. For 1's complement, the instruction used is not instruction, that is not register. For 2's complement, the instruction used is NEG, AX or NEG register. That means the contents of the register will be complemented 2's complement. Then program control instructions. Program control instructions will transfer the control of the program from one place to another place. There are two types of program control instructions. One is conditional, another one is unconditional. So conditional means it will check the conditions of the flags, sign, zero, carry, parity and overflow. Then the control will be transferred to the specified location. Unconditional means without checking any condition, the control will be transferred to the specified location. So unconditional, the instruction used is JMP, address. So without any checking of any condition, the control will be transferred. Conditional, it will check and transfer. And the machine control instructions, it will control the operation of the processor. So halt, wait, escape and lock. Halt means it will terminate the program, end of the program. The halt instructions would be end of the program, so it will terminate the program. Wait means it will check the test pin. If the test pin is low, then only the operation will be, the processor will be initialized. Otherwise, it performs no operation, and escape operation is used for accessing the coprocessors, and lock instruction is to prevent the accessing of buses by the other processor. These are the machine control instructions. And last one is string instructions. String instructions are used for indicating, that is performing the string operations. It is similar operations as moves, compass, that is scans, load, store, repeat. These 4 are used for data, and these 3 are used for repeating the particular instructions. So move 8-bit data means we have to indicate by move SB. It will transfer the data from source to destination. Compare SB means the SI register and DI register contents will be compared, and the status result will be indicated by the flags. And scan instruction will perform the operation, the data in AL register, not AX register, only AL register will be compared with the contents of the memory location pointed by DI register. These 2 are compared, and the result is indicated by the flags. Load means it will transfer the data from SI register, the memory pointed by SI register, to the accumulator. And stores means the contents of the data in the accumulator will be stored in the memory pointed by DI register. And next is repeat. So it is a prefix instruction, repeat a particular instruction until the CX count register, CX becomes 0. And repeat equal or repeat Z means whenever the data in AX register or AL register is compared with DI register, if they are equal, that is 0 flag will be set. Then until this the instructions will be repeated, or CX equal to 0, both the conditions it is applied. Similarly, loop instruction. Loop is also a prefix instruction to repeat number of instructions. So repeat instruction is used for only a particular instruction. Loop is used for number of instructions, particular number of instructions for repeating number of times until CX equal to 0. So string instructions, the instruction set is over. Then we will go for addressing modes. Addressing mode means the to specify the location of the data. Number of addressing modes. One is direct addressing, indirect addressing, immediate addressing, register addressing, then implied addressing, based addressing, indexed addressing, and relative addressing. We will see one by one. First one is direct addressing. Direct addressing means the address of the data is given in the instruction itself, that is as a part of the instruction. So for example, we can take move AL comma parenthesis 1300, that means the contents of the memory location 1300 is transferred to AL register. If it is 16-bit data, move AX comma the address should be specified as inside the parenthesis, that is 1400, like that. Similarly for addition also, add AX comma 1300, like that we can go. Then indirect addressing means the address of the data is stored in a particular register. That register will be the part of the instruction. Example is move AL comma DX. That means the contents of the memory location pointed by DX register. So the BIU, that is bus interface unit, goes to DX register, then find out the contents of DX register, then that memory location, contents of that memory location pointed by DX register is moved to AL register. Then immediate address. there is no problem. That is, the data is a part of the instruction. Data is specified in the instruction itself. So here move CL comma 12 example. That is, here the data C12 is moved to CL register, and we have to take care here. If we are using 8-bit register, 8-bit data should be used. If it is 16-bit registers, 16-bit register is used, then 16-bit data should be used. So move BX comma 1400. Like that, we have to take care the register use and the data here. Then register addressing, both the source and destination should be registers. Example, move AX comma CX. That means the contents of CX register is moved to AX register. Here also we have to take the register, number of bits in the register should be same. Then implied addressing means the operation is performed on only accumulated data. Example is DAA. That means decimal adjust after addition in the accumulator. Then based addressing, it is a type of indirect addressing. Only the register used to store the addresses BX register or BP register. Example is move AX comma BP. That is, the address pointed by BX register, the BP register is moved to AX register. Then indexed addressing, it is also a type of indirect addressing. Instead of base registers, we have to use SI register or DI register. So this is especially used for string instructions. So the example is move AX comma SI. It should be mentioned inside the parenthesis. Then relative addressing is used along with based addressing or indexed addressing with a displacement of 8-bit or 16-bit. So the contents of that base register or index register is added with the displacement of 8-bit, or here 1, 2, 3, 4 is a 16-bit. Then the contents will be moved to the accumulator, that is AL register. Here the contents of AX register is stored into the register memory location pointed by BP register plus this one displacement 1, 2, 3, 4. Then we will go for the programming. So programming with 8086. For programming part, first we have to define the problem. So suppose if you are going to add two 16-bit datas. So 16-bit datas 1, 2, 3, 4 and 5, 6, 7, 8 are added, then the results would be stored. Then we have to go for algorithm. In the algorithm, first we have to step by step define the algorithm. First we have to store the data in the registers or in a memory. So store data in memory 1200 and 1201. Sorry, 16-bit data, so it should be 1202. Then retrieve the data to AX register and another data directly added from the memory. Third one is add the data. Then we have to check for carry. If carry rises, we have to store the carry also, otherwise store the result. Then check for carry. If carry Then go to step 6. Sorry, if no carry. If carry, we have to go for step 6, that is storing the result. If carry rises, then the data carry should be incremented. So increment carry register. Then sixth step is store the result. And finally we have to terminate the program. So we have to write the program according to the algorithm. So in the algorithm we told that the data should be stored in the memory locations 1200 and 1202. So we have to write move AX, 1200. So that data in the memory location 1200 is transferred to AX register. Then directly we can go for addition operation. Add AX, 1202. So addition operation is performed. Now we have to check for carry. We have to write as the jump on no carry the specified location J, that is XX. Otherwise we have to increment the carry register INC CL. So the CL register is already initialized for storing the carry, so that should be incremented. Then store the result, the label store move 1400 comma AX, then move 1402 comma CL, then call the terminate the program, that is HLT, machine control instructions. We will see another program, that is code conversion, like ASCII to binary and binary to ASCII. We know that the hexadecimal numbers, that is binary numbers, hexadecimal numbers is 0 to 9 and A to F. And ASCII numbers, these are represented by ASCII numbers by using 30 to 39, and A is represented by 41 to 46. So if we want to write a program to convert this hexadecimal to ASCII numbers, what is should be done? We have to add 30 up to 09. Then for A it should be 41. So we have to consider. Then we have to compare the data whether it is less than 9, that is 0A in hexadecimal. If it is like that, we have to add 30. Otherwise we have to add 37 in hexadecimal. First get the data from the memory. Second step is compare it with 0A. If it is less than 0A, 30 should be added. Otherwise we have to add 37. If AL register is less than 0A, add 30. If AL is greater than 0A, we have to add 37. Then the result should be stored in the destination address. Then terminate the program. So first we have to get the data from the memory location. So we have to write move AL, 1400. So that means the contents of the memory location should be moved to AL register. So we have to get the data is transferred to the AL register. Second step is compare to 0A, CMP AL, 0A. It is compared with the immediate data 0A. Then we have to check for carry, jump on, no carry, we have to go for somewhere. If carry rises means the accumulated data is less than 0A. So carry rises means accumulated data is less than 0A, we have to add 30. Otherwise, we have to add 37. So add 07, add 30. So this location should be comes here, exits. Then store the result, move 1500, AL, then terminate the program. So here jump on no carry means accumulated data is less, the control will be transferred to this state, add 30. So 30 is added. Suppose if you are giving the data as 07, it will check, then it will go here. Then add 30, the result is stored in the accumulator. That is 39, the result will be 39 is stored here. If it is greater, then 07 is added, then 30 is added. So totally 37 is added, the result is stored in 1500. Then the terminate the program.